How's it going? Good morning. It's time for another daily coding problem. This is where I take an interview question that's been asked at some tech company and I see if I can do it because I'm not that great at these. So I'm doing them every day so I can get better. Let's take a look at the question we have for today. This comes from dailycodingproblem.com. It is an email newsletter. Every day they send you an email with a new problem. Today's problem comes from Twitter. Implement an autocomplete system that is given a query string, S, and a set of all possible query strings. Return all strings in the set that have A as a prefix. It's kind of hard to read. I feel like these should be like made monospaced. Code formatting, right? Oops. S A. Okay. Given a query string S and A. Probably should have did this before I started recording, but I just copied this out of the email, so I don't want to spend too much time reading these before I hit record. Okay, excellent. Let's try this again. Implement an autocomplete system that is given a query string S and a set of all possible query strings. Return all strings in the set that have S as a prefix. Okay, this is a normal A. Okay, for example, given the query string DE and the set of strings dog, deer, deal, you should return deer and deal. Cool. I think this one's pretty straightforward to understand. It just might be a little tricky to write in an efficient way, right? So I think this is pretty obvious how we can do it inefficiently. We can just take the query string and iterate through all of our words that we were given and return everything that starts with that, right? So let's just write that first, and then we can improve it if we have time. Oh, I forgot to start my stopwatch. Shoot. So I have an hour to do this. Been getting done a lot quicker than an hour usually, but I want to give myself some kind of upper bound. So let's open up solution_test.rb. We are going to use Minitest Auto Run, which is included with Ruby, so we don't have to install anything. And then also Minitest Pride, which we're going to use for color in our test output. And then we also need to require the file that we actually want to test, which is our solution. So let's go ahead and describe our solution. And we'll describe our method that we're testing, which is going to be called, let's just call it filter. And then it returns all words that begin with the query. I'm just going to call this search, I suppose. Okay, that seems good. And then we were given an example. Let's just use that for now. So here's our words. So we'll do solution.search and we'll pass in some words. And we'll pass in a Q. This is going to be DE. All right, something like that. And we assert equal. We should get back the set of deer and deal. And I'll make this a string array as well. Perfect. Okay, that line's a little long. Okay, this looks good. Let's run it. Obviously, we're going to get a failure here. Okay, excellent. It can't find our solution file, so we will create it. And we might as well jump the gun here and create our method that we're testing because we know that's going to fail next. This is going to take a set of words and it's going to take a query. And now we should be getting nil. Yep. So actual is nil and expected is deer and deal. So let's go ahead and do the stupid way here and then we can make it more efficient. So words.select do word. Word. I'm pretty sure we have like a begins with or something in Ruby, right? Let's double check that. ABC dot begins. Is that a thing? Begins is not a thing. Begins with is not a thing. Starts with. Ruby string starts with. Okay, this is actually pulling up in another window here. Let me make this way bigger. Start with. It's singular. Right? Make this way bigger again so that you can see it. So we have start with. That's what we want to use. Oh, oops. Ruby told me that already, didn't it? So abc.start with AB. It's going to return true. Excellent. And if we pass in a C, it's going to be false. Perfect. Okay, we just ran our test and we're getting some different stuff back. And that is because our test is set up incorrectly. This is a string array, and so it's including the commas in our strings. Let's try it again. Ta-da! Okay, perfect. All right, so that was pretty straightforward. So one issue with this, I guess, is we're going to have to filter through the entire list every single time we want to do a search. So in the case here where we have DE and 3 words, it's not a big problem. But if this was a database of like all words in the English language or something, that would be pretty terrible, right? So one way I'm thinking about improving this is to cache our words in advance. So this won't actually improve anything for these tests because we're only searching one thing at a time. But let's say if we were to, start up an application and cache a whole dictionary, then from that point on, it can be much more efficient, right? And the way that I would do that is probably with a hash map. And so we can just decide how deep we want to go. And, we can say maybe just do 3 letters for now. And so we can do like A, B, C, and then this would be all the words that begin with ABC. So in our example here, we'd have A, we'd have some more characters, and then we'd eventually get to D, which would have an E map under it. And then if we're doing 3 deep, that's D, E, and then what? We got another E? Yeah. Oh, and this would be an array. And this would have the word deer, right? Yeah. We can try that. I think that would be pretty efficient. So this would mean that we would, for this example, we would grab the map D and then grab the map E, and then we would flatten that and just filter through those words exactly as we've done here, right? So let's do that. And because we're kind of doing this like caching thing now, I'm going to make this, instead of a class variable, I'm going to make it an instance method. That way we can create a search or create a solution, and then the dictionary will be cached, and then we can query it as many times as we want after it's been cached. So that means this is going to be .new with words. And then .search with Q. Right? And then to break this up even more, we can create our solution up here. And then search it here. Right? And let's go ahead and make those same changes here. So we have a search now. We have an initializer that takes words. We want to save those words. Something like that. And now we want to search with a query. And then, sorry about that, doing some Command Tab action there. We'll search with a query, and this will be essentially the same, right? Something like that. Let's run our test, see if we got any typos we got to fix. Okay, so now we're back where we started, but now we've got a instance method. So now the caching will actually work if we wanted to perform multiple searches. And then instead of words, maybe we create something that we can use down here called, what do we want to call this? Dictionary or something? Tree, word tree. It's kind of a tree, right? I'm going to call it dictionary. Yeah. And then we'll again, we want to cache these results. So we'll do dictionary. Load up our dictionary. And now this is where we need to build our map. So we can do a start empty, go through each of our words, and just to save myself some typing, I'm going to call it dict. For our word, we want to grab the first three. Word.chars .first three. We'll call those keys. And then we can take the first key, create a dictionary. If it doesn't exist, then we can take our second key. That's going to be this. Right. Create our second key if it doesn't exist. And then create our third key if it doesn't exist. Yeah. And our third key is going to be an array. And then we can push onto that our word. Right? And then we'll go ahead and return our completed dictionary. Right? I think that looks good. And now that we've returned our completed dictionary, we'll save it in there. Now we need to use our dictionary in our search instead of words. So we'll leave this here because we are going to use that, but first we need to pull it out of the dictionary. So we'll do dictionary. We need to get our keys first, right? So we'll pull this into a method maybe. We'll call this keys for a word. Perfect. And then we'll type this out for now. See if we can clean it up in a moment. Grab our first key, grab our second key, and then of course this isn't going to work as we've written it right now if we have less than, if our word is less, or our query is less than 3. Oh, I guess that's what we're about to find out, huh? Cool. So this is actually going to fail, right? Because our test has a query that only has 2 characters, but we're using 3 to try to pull open the dictionary here. So how are we going to handle when there's less than 3? Oh, I see. Got it. This is where we're talking about doing flattening, right? So what we can do, so first 3, let's see what first 3 is going to return when there's less than 3 elements. Okay, it only returns as many as there are. Perfect. What does it return if it's empty? Okay. Great. This is actually pretty good, right? So what we want to do, so this is only going to have 2 elements in it for our test. And we can do, let's see, we get all of our keys, dot each do key. And then we can do dictionary dot fetch of our key. And oh, maybe this would be interesting, right? Let's do inject. Inject with our dictionary. Key dictionary. We fetch it and we keep fetching while we have keys. And this will be our words. Right? Let's make sure flatten works as we expect. So if I have a hash, what happens if I call flatten on that? Okay. Interesting, interesting. Does it just keep going? So now we've got our set of words. Now we can filter our words. Wow, I just wrote a lot of code and we haven't run a test yet. There's bound to be a mistake in here. Let's try running it. Excellent. Syntax error. Unexpected end of input. I am missing a do. Undefined method fetch for dstring. Okay, great. Let's figure out why. So this is let's hop into here. Let's add our pry up top. There we go. Hop inside our loop, see what we're doing. I spelled binding wrong. Excellent. So we have a key. Ah, I got my parameters wrong. They're in the wrong order. Let's try flipping them. All right. Everything worked. Cool. So now we're caching into an array in theory, or into a couple different maps. Let's try adding some more tests here so we can make sure this works. So I'm going to take our solution class. I'm going to just add a bunch more words to it. And then we can add some more test cases after we've got more words. Okay, let's make sure that still works. Perfect. And okay, so what do we want to add? Cat, mouse, pizza, taco. Let's add some stuff that starts with the same. Car, card, sandwich, sand, Sammy. Let's sort these. Run our tests again. Does it work? All right. So we're getting a failure. Oh, the order. Huh, okay. So if we want our test to be consistent, we might as well sort these things, right? And that means our search results need to be sorted as well. I can take the sort out now that everything's alphabetical. Cool. All right, so we didn't break anything doing that. Let's add some more tests though. So we want to search for car. See what that gives us. That should give us car and card. Sweet. Okay, what's another one we can search for? Let's try sand. That's an even longer word. And actually, I'm going to do SA. We'll do a couple with this one here. Okay, so that should give us those three. So let's do Sammy, sand, and sandwich. Excellent. And then let's try a longer query for just sand. We haven't tried searching for anything with 4 yet. And that'll give us just these two. Sweet. All right. I'll close out our test. I think we're done working with that for now. We can still run it in the background. It's been about 22 minutes. So I think we still got a few minutes if we want to try cleaning this up a little bit. Let's see what we can do here. Our initializer's fine. This load dictionary looks a little janky. What's a nice way to clean this up? I think our keys looks good. We can go through each word. How can we initialize here? Should be able to initialize a little better. So I believe I think we can initialize hashes with a default value, right? Maybe. Somehow. Let's see. Let's try hash.new with an array. And then a of 1. Okay, so it worked with array. Let's try hash.new and then we get a 1. Okay. That seems good. So we can make a hash with hash as the default value. Where is this blowing up at? 32. Okay, it's blowing up in this situation. Okay, that's because this is returning a hash, and I'm pushing word onto hash. Okay, let's try this. Dictionary, 0 of keys. I don't think this is going to look any better. If I got to put all these blocks in. Yeah, I really don't. Yeah, I really don't. Something we could do, though, that would be fun is just to call a sort here as we load our dictionary. This way, when we initialize everything up, whatever words have been provided, we sort. And yeah, I think this is good. I think this is pretty good, and we can do multiple queries. Yeah, let's throw this up into a commit. Okay, so we have our README that we improved. We have our solution, and our test. Add solution for today, which is the 11th, and push it up. Cool. Okay, well, that was fun. See you again tomorrow, I guess, huh? We'll see if we get another email from Daily Coding Problem. If not, we'll grab something off LeetCode and take a look at that. Thank you. Bye.